Problem 2. Calculate the design load carrying capacity of a compound column consisting of ISHB 250 at the rate 500.31 Newton per meter, with one cover plate of 320 by 20 mm on each flange as shown in figure. The length of column is 4 meters. And assume that its one end is fixed and other end is hinged. Assume Fy equals 250 Newton per square millimeter. Solution. Step 1. Coming back to our problem. That is collection of data with the help of IS Handbook number 1. A diagram of built-up section is drawn on the screen. According to IS Handbook number 1, we can have following specifications which can be used as data to solve problem on a given section. Or we can design any section according to need. Properties of ISHB 250 at the rate 500.31 Newton per meter. Here. Length of the member L equals 4 meters. Equals 4000 millimeters. W equals weight of the section is 500.31 Newton per meter. A equals sectional area. Equals 6496 square millimeters. H equals overall height of the section. Equals 250 millimeters. IZZ equals moment of inertia of section about XX axis. Equals 77.365 into 10 to the power of 6 mm to the power of 4. IYY equals moment of inertia of section about YY axis. Equals 19.613 into 10 to the power of 6 mm to the power of 4. RZZ equals 10.91 centimeters. Equals 109.1 millimeters. RYY equals 5.49 centimeters. Equals 54.9 millimeters. For rolled steel cover plates, A equals sectional area. Equals 320 into 20 equals 6400 square millimeters. B equals width of the plate. Equals 320 millimeters. T equals thickness of the plate equals 20 millimeters. IZZ equals moment of inertia of section about XX axis. Equals 320 into 20 cubed upon 12 millimeters to the power of 4. IYY equals moment of inertia of section about YY axis. Equals 12 into 320 cubed upon 12 millimeters to the power of 4. Now for built-up section. A equals 197.71 square centimeters. Equals 19,771 square millimeters. Calculate moment of inertia of built-up section using parallel axis theorem. IZZ equals 77.365 into 10 to the power of 6 plus 2 times 320 into 20 cubed upon 12 plus 320 into 20 multiplied with 125 plus 10 squared equals 311.07 into 10 to the power of 6 mm to the power of 4. IYY equals 19.613 into 10 to the power of 6 plus 2 times 20 into 320 cubed upon 12 equals 128.84 into 10 to the power of 6 mm to the power of 4. We can have radius of gyration about both axes. RZZ equals square root IZZ upon A equals square root 311.07 into 10 to the power of 6 upon 19,771 equals 125.43 millimeters. Similarly, RYY equals square root IYY upon A equals square root 128.84 into 10 to the power of 6 upon 19,771 equals 80.73 millimeters. Step 2. Identification of most probable axis of buckling. Calculation of least radius of gyration. Since RYY is less than RZZ, the design compressive strength is governed by the effective slenderness ratio. Column will buckle about YY axis. Also R minimum equals RYY equals 80.73 millimeters. Step 3. Calculation of slenderness ratio. Slenderness ratio about YY axis. Lambda y equals KL by RYY. Here effective length factor K equals 0.8 for the column with one end fixed and other hinged. Refer IS 800-2007, Table 11. And R minimum equals RYY equals 80.73 millimeters. So, lambda y equals 0.8 into 4000 by 80.73 equals 39.64. Step 4. Identification of buckling class. Refer IS 800-2007, Table 10. For all built-up section buckling classes see. Step 5. Calculation of design compressive stress FCD. Refer IS 800-2007, Table 9C. For lambda y equals 39.64. For buckling class C and for Fy equals 250 Newton per square millimeter. With the help of interpolation, the design compressive stress FCD equals 198 Newton per square millimeter. Step 6. Load carrying capacity of the member or design axial load on column. PD equals AC into FCD equals 19,771 into 198 equals 3,914.65 into 10 cubed Newton or 3,914.65 kilonewtons.
For complete course and step-by-step illustration, please subscribe full course on Structural Analysis and Design app. Also subscribe YouTube channel Matrix Digital Solutions. Thanks for watching.